By 2020, the UK must increase its green energy production from 2 to 15%. And as we're Europe's windiest country, harnessing this resource could be the key to helping us meet this target. A single onshore wind turbine can meet the energy needs of 1,100 households a year. But there is a serious problem with them. Across the country, the construction of thousands of turbines, enough to provide power for 3.4 million homes, are on hold because of the unique effect they have on aviation radar. Air traffic controllers use bounced radar pulses to locate moving objects. Because of their spinning blades, turbines reflect these pulses in the same way as an aeroplane. So air traffic control can't distinguish between a wind farm and a road-moving aircraft.
At the moment, the problem is vast. There's up to 6 gigawatts of power is being held up in the process because of the aviation problem. There is a huge pressure on everybody to get this problem solved. The aviation problem affects many different stakeholders in the aviation community. On the MOD side, we have RAF bases, and they have air traffic control services and air defence services to safeguard. Also, we have civil airports, and then on top of that, we have NATs, who are responsible for the en route services, the transatlantic flights, etc., that don't even stop here. It really is like a motorway in the sky.
But now, engineers believe they may have found the solution. Stealth technology. For over 6 decades, they've been working on ways to make boats and planes disappear from enemy radar. And now the team are applying these techniques to the wind turbine problem.
Ready?
Yeah. Very good one.
Clear, yep, it's looking good. Around about 30 dB. Stealth is the shape of the vehicle and it's the materials that it's made of, so you either reflect a signal away from the radar that's looking for it in a different direction, and you do that by shaping the aircraft or ship, or you make it out of something that absorbs the energy that's been sent out by the radar.
QinetiQ don't build wind turbines, so they're working with one of the world's biggest turbine manufacturers, Danish company Vestas, to solve the problem. It's been a hugely complex challenge. Because every inch of a turbine blade has been precisely engineered for maximum performance, the shape, weight, or manufacturing process can't be changed. Engineers here are working on a special solution to add stealth material layers into the composite skins of the blades. Almost weightless, but complex.
These guys are just measuring and marking the position of the various materials so that we get them in the right place. It's important that we put these materials in exactly to within a few millimetres, otherwise we could upset the later joining of the two parts of the mould. It's nice to get away from computer models of what we're doing and actually work with these guys and see it coming together as a component.
The composition of these layers is a closely guarded secret, but they work by absorbing most of the radar pulses, so only a very small amount is reflected back. With the weakened returned pulse, the turbines become distinguishable from aircraft to radar operators. Initial tests are positive, and the teams are now building what will become the world's first stealth turbine. The success of this project could mean cleaner energy for everyone, with a British company at the forefront of a multi-billion-pound expansion worldwide.